out of here. Your collective posterior is out of here. Tuchuses, if that's the plural. Tuchai? Yeah, keisteri, yeah, keisters. You see, the tush is a much better, it's a much better name. The derrieres, okay, permanent vertical smile, named in song and story, that type of stuff. I mean, you have a lot of those. The back of your front, the fleshy part. That's all from a show called MASH from about 50 years ago. I know. Don't even ask. It's all right. I can live with it. It's okay. When you're old, you can accept this stuff. I used to have a complex about it. So I told my best friend, same age, we're the same age, only my best friend for, I don't know, 60 years. And and interestingly, in the end of his career, he was teaching science to 7th graders, in junior high. And I go, all I know is when I'm so far away, they walk into class and they think their grandpa or older. Someone older is teaching. You can't relate. I can't even. All right, so these are the extraocular muscles you remember. There's better drawings than I have. Yes, you do need to know them for the exam. I'm almost 100% sure. I did send the study guide. Okay, I sent it. I incorporated it as you requested on the blackboard under Unit 2. And I'm having difficulty logging into either. For whatever reason, there were some big problems with AWS, Amazon Web Services. I don't know if they're impacted with that giant cloud network, but I can't seem to get where I have access to all the software from these textbooks. And a lot of times they do come with outlines, okay, of the chapters. They used to, whether they still do now, I don't. Those are from older editions I don't have access to. I'm just, because you asked the question, and it's fair. Fair question. I mean, anything that makes your life easy, I'm happy with. Because I realize you guys, not everybody will appreciate it. And I'm saying this to all of you sincerely. I mean, I know I had the luxury of not having to worry about bills when I was in college or in medical school. I mean, many of you have to work. Okay, you have other responsibilities, family. It's not easy. I understand it. I had one job: go to school and get good grades. So my parents could go, my son, the doctor. It's a Jewish family, mom and dad's dream. My son, the doctor. Okay. To understand, I do appreciate what a lot of you are going through. Is this a question, or are you just putting your hair back in place?
Question.
Go ahead.
So exam 2 is joints, central nervous system,
and peripheral nervous system. There's a study guide.
It's fun.
Thanks for the compliment.
Anything else?
Not that I'm aware of. I'll do the recording tomorrow.
So the eye stuff is on.
The eye is not on it.
It'll be on our practical.
Yeah, undoubtedly, the practical will be a labeling practical. But you're not getting the practical will have nervous system, eye, and heart. So I have to do the heart. So you won't see that practical for a couple of weeks. Are you good with that?
Yes, sir.
I mean, it's okay. I can take the hit. So I said to the other class, if you don't feel like taking, remember, October 31st, you can drop out. Wait a couple of years, maybe I'll retire. You can come back and take it with somebody else. I'm joking. All right. So, I mean, you don't have to go through all this. We looked at the muscles, the hole they go through, or the common tendinous ring. I don't care. This was the drawing. You saw something very similar to it. We did the cranial nerves. So again, I remember that LR6 SO43, and you're probably in good shape. And so, I mean, I don't need to go over them again. They're illustrations. So you can kind of see how the oblique, how it will pull it in one direction or the other. Whether the superior rectus and the superior oblique will rotate it in a particular direction. So I'm not going to ask you where it ends up or some of that stuff, just so you know what nerve innervates one muscle. So it's more about the cranial nerve than it is that. Okay. So, and here's basically the summary. You can see basically three, the oddballs, superior oblique, 4, the SO4, LR6, all the rest are 3. Very good. And this is what happens when they're not coordinated. This is another reason we get double vision, okay, and a lot of different things. Neurological disorders, paralysis, trauma, certainly, any of these kinds of things. But they're indicative, and that's particularly in concussion protocol. That's what you're looking, anything, it's all about asymmetry. And that's all of the time when you do neurology and other exams. If you're doing muscle testing, you test both sides. If you're doing reflexes, both sides. You get used to what's normal, and then you know whether someone is hypo or hyporeflexive or hyperreflexive. It's hard to do. A lot of times when people are so cognizant of reflexes, it's good to have them close their eyes and do this. Because they may focus on their knees knowing they're going to get whacked in the knee with a neurological hammer. So you have them pull this, do this, close their eyes, and it distracts them from consciously trying to control their reflexes. Or not, they almost will do it prematurely. I want to show them I have good reflexes. Okay? So all this stuff is relevant. I don't know where you guys are going career-wise, and gals. I'm using guys plurally. Where you folks are going. I want to be politically correct. You know me. It's like when we talk about dwarfism. I was, are you supposed to say that? Probably not. Little peopleism, midgets, munchkins. I'm just. That always gets them. Oh God, cross-eye. This, and again, this is more about inherently weakness that's there. And the interesting thing, there's lots of it's my middle one we had him looked at. We went to Children's. We saw their ophthalmologist, a big ophthalmology group out of Children's. And he looked at it and we go, well, does he need surgery? He goes, no. And he recommended some exercise which kids don't do anyway. And they said there was a very famous tennis player, still alive, who won the U.S. Open, the French Open, named Yvonne Lendl. And he goes, his strabismus is worse. And he doesn't need any type of surgery. So we make more of it than we should, just for context. This is what you're going to see in the dissection. If you look at the big model up here, which is really very good, you're going to see 3 layers. The outermost layer here is fibrous tunic. Darker colored one here is a vascular tunic, and you really can't see because the interior here is the nervous tunic, which is effectively close. Okay, that's what you can see it very well. You can start to see them from here. Big. You can see the white. You can see. So this is sclera and the clear area in front here in this corner. That's what we want to start with, to look at these layers or tunics. So it doesn't matter. You can say fiber. If you label a diagram, you don't have to say tunic. You can say fibrous layer, vascular layer, inner layer. Inside, what keeps the eyes, the shape that you'll be seeing there, even though you won't see so much, there are 2 humors. Humors are terms that are used for fluids, historically in that. But we don't use them anymore. They stuck around the eye. And the lens, you will see, divides these into 2 chambers. You see the lens is very distinct, but the lens will be opaque. It's clear normally for what is happening. But when somebody dies, things cloud over. There's a mechanism that keeps it Good, that's true for both the cornea, which is clear, and the lens. And that's why typically, if somebody, older relative, dies, I never impose their eyes to be closed, because people don't want to see grandma or grandpa's full side open. That's just, and typically what they do is very disconcerting. Like you see somebody who's lost their sight and doesn't have dark lenses on or something like that. Here's the lens. The anterior chamber is filled with aqueous humor, the water-based fluid. The most important thing to understand about that's the source of glaucoma. Glaucoma is increased pressure. Like any fluid in the body, with some exceptions, we make a certain amount every day, so it drains every day and stays in balance. And routinely that is checked. The eye exams, we've had your eyes tested recently. It's all done with very advanced machines. They used to have to basically numb the eyes, drops, and then put a pressure sensor on. Now it's done with air air. If you have had your eyes tested recently, you put your into this machine that does about 16 different things. You're very sophisticated when you're going to just get your prescription, or if your own prescription, it's okay, it's whatever. That's the aqueous chamber. So the fault is if it builds up too much pressure and that can cause blindness and surgery. That's something that can be treated surgically, but conservatively there's a variety of drops that are used for glaucoma. They're very, very effective. Vitreous humor, unlike the aqueous, is something you're born with. So that doesn't really change. It stays with us throughout your lifetime. That's very useful forensically. It's a gel-like. You will see it here. So it gives the eye that sort of, I'm working to squeeze eyeballs, but you can squeeze here, and you feel that, you can tell that there's something in there that's giving it a certain amount of, you feel that it's liquidy or soft and it retains its shape. That's the vitreous humor, or vitreous stuff. You will see that, and the lens will be part of it, so to speak. You have to be careful as that comes out, because it really is what keeps the retina, part that you see with, pushed up against here. If not, the retina can detach. But detached retina is something we see with trauma, so it has to be repaired surgically. The advances in eye surgery, I can't even begin to describe. I was in high school. We had a couple of history teachers, both excellent. One guy, he was going to be not here, going to be not here for like 2 weeks. He was having a detached retina repair. In those days, he had to stand flat on his back after the surgery, sandbag in, unable to stand up, sit up, or anything like that. The same was true if they had cataract surgery. Now, if somebody does cataract surgery, they go home in a couple of hours, and the instructions are basically not to lift anything heavier than X. And, try to keep your head as upright as possible. Other than that, there's no restriction. You go back to next one. It's like there's people who were functionally blind 50, 60 years ago, and they do them just like that. I was operating out of St. Francis Central, Central Medical down where the arena is now, and this doctor, they have a factory doing cataracts. He had run in 2 rooms. In the morning, he put like maybe 2 dozen sets of lenses, removing cataracts and putting lenses. He's just going room to room. What does he use the cash for? We had a wonderful, very, very well-known doctor. His group's still around. It's HURIT, Dr. Biol. And he's very, very, very well-known. This one, so probably still bears his name. I knew him. I played golf with him one time. He was a really good guy, but just a really good surgeon. Nevertheless, so you have these layers. So fibrous, vascular. The inner layer is the retina. So in the same, what you're seeing here is a really good illustration. It doesn't. The retina is a delicate membrane. Some of you, when you open that eye, it will seem like it's coming off. It's almost like, what's this kind of fatty, kind of yucky stuff? that's kind of adherent to something. That's actually the retina. If you're careful dissecting it, it should stay adherent, and you will even see the pattern of fibers. Because remember, it's a sensory nerve, so all the little nerve endings are through here, and the nerves they sense everywhere here, and they all lead back to this area, and as they exit, they form the optic nerve. And I'm going to describe the sensory apparatus to you in a little bit without going into the physiology. And all of that comes in. You notice, like in nerves, again, the blood supply is on the interior. With muscles, it's from the exterior. Remember, we were looking a little bit at nerves before in lecture. And so that is the optic nerve that's exiting. It'll form the optic chiasm where they cross over, like we saw in the sheep. So that's a relatively thin, delicate layer, and you can actually trace where the fibers are going to, and that will be the optic disc, which is also known as the blind spot, where there are no sensors there. The names of the sensors, and we do this more in physiology, are rods and cones. There's about 20 times as many rods as cone. Rods are basically black and white or shades of gray, and they have, their size, shape, silhouette, night vision, peripheral vision. That's rods. And you have very, very little light if necessary. Cones for color, CO for cone, C-O-N-E-S, and CO for color. It's all because of the shape of the tiny endings that constitute our visual apparatus that are there. And in between that layer, you have this pigmented layer, which commonly is referred to as the vascular layer. Most of it is the choroid until it extends anteriorly toward the lens apparatus. Okay? That choroid is the best way to describe it is if the blood supply is important for nourishing the retina or the nervous portion, but also the degree of pigmentation prevents scatter. I mean, it's a little less familiar today, but did you ever have one of the old style cameras that film as opposed to digital? Did you ever drop, little cartridges and things like that? Even before they had cartridges, they had rolls of film, like 35 millimeter film. And you had to be very careful you had to make sure you wound them completely, and then you could remove them, because if there was any part sticking out and you exposed it to light, it was gone. And so and what we used to do, I mean, sometimes you'd bring it to a photography place, and they would have a little, a black, and they would get in there with their hand. They'd have a way to get their hands in there and release it without exposing it to the light. So it's not that easy, and you do all the developing would be done in a dark room, basically with solutions rather than necessarily, or even automated. It was done in a dark room. When I did x-rays in my office, we dipped them. So I had a little closet that I had water in. I have cold water running in, and I had a red light, which is what you use. A red light was designed so it wouldn't expose the x-rays, and I dipped and dried my own x-rays when we took them. Now everything's automatic. Eventually I had a Polaroid system, which was a dry system that worked fairly efficiently. All my years of experience, this should be, boy, he did all that stuff. Now everything's so freaking digital, it doesn't matter. And the quality's thousands times better. There's less mistakes. It's so easy. You get it, you put it on a flash drive, put it on a disk, drop boxes, whatever that means. That's like where I return the DVDs to the library. Pre-streaming. Here's the vitreous, which you'll see. Here's the lens. Anteriorly, this is the ciliary body or ciliary ganglia. It comes this way, and this is the apparatus that attaches to the lens. And what happens when the pupil dilates, effectively, it's a circular muscle that opens the pupil, and in doing so, it stretches. These are called suspensory ligaments. That's something else you will be able to see. You'll appreciate what's left of them attached to the lens, and what they will do is they cause the lens to flatten. Our lens flattens for distant vision, and when your pupils constrict, basically it closes this, but it relieves the tension, and this becomes rounder. And in that way, it changes the refractive index. So basically, the whole idea is to adjust this, the opening, with little light, we open it wide. With a lot of light, we close it. For close vision, it's very, very narrow. For distant vision, it's quite wide. And what it does, by altering the lens simultaneously, it directs the vision to the point of maximum vision. That's what your glasses do, or your contacts do. Whatever corrections you have, they point it to here. I mean, and I'm sufficiently nearsighted, I can't read that, without this on. And that's the fovea centralis. The macula is the wider area, the little pit, which you will not see on very well. And it's not something I know how well you would see it on the human eye. Okay, is the fovea centralis. That's where you have the highest cluster of cones. That's your maximum vision. That's what your glasses do. They adjust for curvatures of the eye. That's called an astigmatism. It's not two words, it's one. astigmatism. Because I always thought it was, I have a stigmatism. One, maybe two. But really, that's a curvature of the eye. That's your regular. I'm going to qualify this now. The eye is not a long suit. Bones, joints, nerves, digestive, blood, got you covered. Eyes, I'm reading to you. I told you I'm afraid of the eyes. It's just not an area I get excited about. Fair disclosure. So you will see this, and this little serrated edge, you will see this ora serrata, the serrated opening. It's really focusing on the end of that pigmented layer as it's approaching the lens. Again, the lens is the divider. You'll see the iris, the continuation of the pigmented or vascular tunic. You will see, obviously, the lens itself. And when you see from the inside, you'll be able to identify the cornea, but it will be clouded over. Interestingly, inside some of us have great night vision, some of them are like me, and I'm like holding on to stuff. I'm terrible. I just am. And animals have wonderful night vision. Inside their eye, and you will see it with the cow, or you will see it with the sheep, there's a structure called the tapetum, Tapetum. It's like a reflector. Like if you were going out for a run at night or for walking the dog at night, maybe you'd have a reflective outfit on, or the dog would have, like a reflective coat or some type of garment on. Effectively, animals have that, so it magnifies, it enhances the ambient light. Very interesting. We don't have that. Some people are really, my eldest, when he was doing his naval ROTC, they do a week with the Marines. They're out in the dirt in the middle of the night. I said, how could you see? I saw great. I mean, it's really very, very useful. The military particularly looks for people if they're going to be doing special op type stuff. He's not a special ops person. He's what the Navy calls a SWO, Surface Warfare Officer. Remind me, I have a great picture, but it was on Facebook, of my two grandchildren. They had like a thing that their school was sponsoring. They built their own little booths. It's like they were going to like a farmer's market or whatever kind of a market and sell it. It's just like little entrepreneurial stuff. Oh my God, so cute. Oh. Great. Okay, so that's the cross section. So fibers, 2 items only: sclera, cornea. Similar construction, different arrangement of the fibers. Opaque, the posterior region protects and shapes the eyeball. This is where those extrinsic muscles, you'll probably feel or see some remnants on the eye. Where the optic nerve exits, the sclera is continuous with the dura mater of the brain. So again, we have a lot of that. Maybe you're starting to see that. When we talked about joints, they were continuous with the periosteum, the capsule. So a lot of structures are continuous with one another. So the transition is when they start to change the orientation of the nature of the fibers. That's I find very interesting as well. So it's continuous with the duro, even though here you won't see it. Again, some of these eyes will be better than others because whoever extracted them from the cow, once the cow was in cow heaven, God bless this cow breeding. This is the cornea, transparent area, clear window. Again, it has different things, and this is the whole idea of when you die. The sodium pumps that maintain the clarity, they stop working. They're a pump. They need energy. And that's why, and that's why it begins to cloud over. A lot of pain receptors. Eyes are very sensitive. The vascular layer, the choroid is the bulk of it. The ciliary body is where it's going anteriorly, and eventually it terminates as the iris. So supplies blood to all the layers. The pigment absorbs light to prevent scattering of the light, which would cause visual confusion. That's the idea of scattering. And we do that a lot. It's like in our, if you go and have x-rays taken at a facility of the hospital, I had them in my office, we put lead. It not only is it protective to people outside of that area, it prevents scattering. It absorbs it rather than have it bounce off. If you didn't know that. And we had that was checked once a year by the state, by DER, Department of Environmental Resources, to make sure. Just to do this stuff. This is easy. We have people who take care of the safety department. I don't have to come in and have my fire extinguishers checked. All of which, by the way, they send you a nice little bill for that. None of this comes free of charge. So the ciliary body, that's involved, again, shaping the lens. And they have a variety of things. What you should really look for, and I should have written it down, but will, the suspensory ligaments. I think they're really important. So you're going to see the remnants. They'll be pigmented. They'll look like little black or blue marks on the lens itself. Those are the remnants of the suspensory ligaments. They're the iris, colored area, we're familiar, and the pupil. Okay, close vision constricts. And again, we'll look at this again comparatively early in the term, next term, about a third of the way when we do the autonomic nervous system. Changes in emotional state, that type of stuff. I mean, I look at you folks when you're taking the exams. For me, it's interesting. There's all sorts of little nuances. And you see, and I was no different. I had a whole little thing I went through when I was exam taking. Everybody has a different way of sort of organizing themselves, and you can see when they're perplexed, when they're looking at, when they're happy, when they're taking my name in vain. Same illustration. So here's the controls. We'll get into sympathetic. When you're angry, dilate. When pinpoint, and why this is relevant, this is how in an emergency room environment, we have a quick clue, because a lot of times when someone comes in overdosed, you don't have any information. If there's a narcotic overdose, pinpoint pupils. If the pupils are widely dilated, think speed, ecstasy, something along those lines. Okay, so the different things. Okay, so that would be something that was effectively excitatory in nature and cause that drug. So different drugs have different things, and you have to treat them differently. I mean, speed and ecstasy, Narcan is not going to help. That's for opioids. That's not an opioid. But a lot of times people take mixtures. But not that I don't think the Narcan would hurt to use it necessarily. That's a luxury we was in its infancy. We didn't have a whole lot of that available. We had a lot of drug overdoses in our emergency. The big thing, they were mixing stuff. They were making street drugs out of stuff and injecting it. There was an old painkiller that was like an opiate called Talwin. They don't make it anymore. And Benadryl, which is easy to get. And they mix those, they crash the pills, and they crush the capsules, and they heat them up and inject it. It's called soup. So they're always looking for scripts for that. So I have some relationship I have some background in dealing with this. We had a big drug detox and alky detox unit in the hospital that I worked. Okay, the retina. You might remember when we looked at the brain, the retinas were starting to form early on. Even in that one we saw with like the 5th week of gestation. They transduced light. They changed photo energy into an electrical signal that our brain interprets as what you're looking, your gray sweatshirt, your hat, your brown jacket, whatever. Nerves. We'll get into the nerves and glial cells. Basically, we do more about that when we do the physiology of nerves. And again, pigmented on the outside, inner side you're going to see is the nerve. And interestingly enough, the signal comes in, goes all the way through this layer of cells into that vascular layer, and that's really where you're going to see the rods and the cones are embedded. We address this again when we look at physiology. So this is important to know because of the physiological aspects. I'm going as fast as I can. So single cell thick lining, very delicate, covers that ciliary body and the iris, absorbs light. Okay, and what you're going to see when we get into the physiology, there's a lot of stuff about that with regard to photoreceptors. We're constantly, every time they see something, break down and we reform them. It's very interesting physiologically. And so you're going to see the anterior end, the serrated edge that's there. And these are the cells. We get into this as more physiology, but you have receptor cells, what are called bipolar cells, and ganglion cells. So it's an interesting circuit I will show you, which you're not going to have to label it or anything like that, test-wise at this point. I think it's too hard. And if it is one, I would point out exactly which one you have to label. So again, the optic disc or blind spot, rods and cones, 250 million that are one of two types. You got 20-to-1 rods to cones. And then when we start getting into physiology, we'll talk about genetic problems with certain colors of cones not being made. There's only one color of rods. And that's where you get into color blindness. Okay, which is very interesting in and of itself. My dad was colorblind, but that is, what kind of genetic is that? Come on, all you people in genetics. X-linked recessive, very good. So it comes from the mom. Okay. So it came from my dad's mom to my dad. I didn't have any problem with that. He did. Not enough to keep him out of the service, but that's a different story. Right there. My dad spent World War II, fortunately stateside in the Coast Guard. Rods, okay, dim light, more numerous, more sensitive to light. It's not really sharp images. It's much more about sensing. It's something like, you know it yourselves. We live in Deer Central around here. How many times have you been driving in the side, all of a sudden you notice something on the side, off the side of the road, it turns out to be a deer or an animal like that. And how many times has there been something right ahead and go, my God, how did that deer get right there? Right in front of me. I mean, most people who live around here long enough, you and the deer and your car sometimes have an incident. Mine did years ago, about 25 years ago. So cones, and again, these are the areas where near that blind spot, okay, mostly cones, and the fovea, that little pit, best vision. This is the illustration, almost done. And so you can see cones because the sensor portion is conically based. Okay? And then here, rods rather, it's flat here. Here are the cones, that little tip. So the signal, the light actually, you can see the pathway of light. It goes in, hits that pigmented layer, the vascular layer is here, and the appropriate light will trigger either rods or cones. That signal will go to these in-between cells, which we look at when we look at neurophysiology. You see them bipolar cells, we see particularly in special senses like sight, smell, taste, hearing. And then once the signal is sort of transformed, transduced, as it were. The ganglionic cells pick it up, and their long axons going to the brain or to the thalamus to start, they form the optic nerve. And this is what the micrograph looks like. So you can see it. Here's the pigmented layer. Here's where the rods and cones are located here. And then you get the bipolar cells and the ganglion cells. It's just pretty accurate description. So, and this is the way the blood supply, we look at this a little bit more. Vessels are visible in a living person, okay? And this is really important because when you had your eyes checked, they did this also. They were able to find that. That is, in the old days, and we still do on the clinical floor, it's a skill I don't have. You're able to have an ophthalmoscope, and you're able to look inside, and if you're good, a lot of doctors who are good, a lot of times when you would have to have medicine put in your eye, when you get your eyes checked, and the doctor would look in once the eyes dilated. It was when you left, it took a while for that medicine to wear off, so you had to wear like special like tinted goggles, have somebody drive you. It took about an hour. It's pretty hard to see. Now they have the device, and they can show this to you. They can take a picture of it. If you bring along a flash drive, they'll probably give you a copy of it. This, as you can see, is the disc. Notice these vessels. This is what normal looks like. You notice how the vessels are all intact. There's no interruptions. They don't bend irregularly. There's no sharp turns. Okay, you look for that. That is evidence. This is one of the few areas that's super important, where you actually can see arterioles, tiny microscopic vessels, effectively with an ophthalmoscope, which is more or less with the naked eye. And an arteriole in your eye is an arteriole in your kidney, an arteriole going to your heart and the coronary arteries. An arteriole is an arteriole. If it affects one, it affects them all. So why do we look at them? That way, if it's a diabetic, you already can see if they have arterial vascular disease. If they're going to end up with kidney failure, you're going to have a real good clue about that. That's why it's so important. And I will tell you, this is exactly true story that's happened to me. I told you what a heavy smoker I was. I'm going to tell you, I probably wasn't I surely wasn't 35. And I would get an insurance policy, which you typically do when you go into practice, in case something unfortunate happens. And my doctor there, he's looking at my eyes and he goes, you know, Lou, I know you're a smoker. Your eyes are starting to show. I said, what do you mean? He goes, I don't like some of the changes. And so he said, you're going to have to, sooner or later, you better stop it. Thankfully, I stopped. And then I went to have an eye check. It was over for insurance here, it was Highmark, so we went to AHN over to Wexford. And I had this wasn't a family doctor. This was, at least 25 years later. And I stopped maybe 5 years prior to that. The lady who viewed it, who was the optometrist, had the sophisticated technology, looked at it, and she's talking to me, and she goes, it looks like you were a smoker and stopped because you had some damage and now it's being repaired. How's that? That's how sophisticated the equipment was. And I was happy to hear that too. So, I'm sure none of you smoke. You're smarter than I am, considerably. And better looking. And better athletic. So this is the detached retina. Again, traumatic blows usually, I don't know what occasion it, as I don't recall. And again, nowadays we have laser surgery, that didn't exist. Here are the fluids, the posterior segment, the vitreous, born with it. It pushes the surface of the lens and basically holds the retina against the pigmented layer. Plays a role with pressure. Embryo lasts your lifetime. After death, it's useful forensically, sometimes for cause of death. The anterior chamber, aqueous, continuously formed and drains. There's a canal. supplies nutrients and oxygen to the lens and cornea, but also the retina, and remove waste. And they show you the whole, like the diagram of how that all goes. And then, I didn't mean to go so fast, but basically how it exits through a little canal. Here's the glaucoma nugget. Early signs, they're always testing for it, particularly if there's any intraocular pressure, typically yearly after age 40. Typically, if you're getting your eyes checked now with the technology, they're doing it. And then the lens is biconvex, so it's convex this way and that way, transparent and flexible. And again, that same thing with that protein, and what happens with all of us as we age, the lens becomes less flexible. It's much more prone to opacities, whether they're in the lens or whether they're in the cornea. They all have the same name, cataracts. And so lots of different things. Excessive vitamin C, we used to think there was no problem. There's a lot of things. I don't know a lot about it with these aging, diabetes, heavy smoking, intense sunlight. I had the smoking aspect of it. And again, I was very concerned about it. I asked another ophthalmologist, and because my mom was having cataract surgery, which was very successful. And she had been a very heavy smoker, even heavier than I. Because everybody smoked back then. She was a 3-pack-a-day smoker for 30 years. So, and I said, he said, "Oh, you don't have to worry." I said, "I'm not going to get him." He goes, "No, you live long enough, you'll probably get him." Didn't go back to that doctor. Okay, on with the eye. So here's the part to know. So we'll go over this all together. I sent you that link, and this is basically it. So you have to remove some exterior fat, wash it off, etc. You should be able to exterior see. Sometimes they'll actually come with like little bits of eyebrows or eyelashes. I don't know. Depends on how they're removed. You'll be able to see the cornea, even though it'll be clouded over. You'll be able to see the sclera that's there. And what you want to do, you'll be maybe able to see some attachments to the muscles, but you'll be able to, on the back, if you have the cornea, I'll do it better from here. You see the way they hold it. So once you get a lot of the fat off, you'll have it, and you won't have to dissect all the fat. You don't have to go crazy. Take some scissors and get rid of some of it. That little nub you'll be able to feel with a fingertip in your glove. And that's the stump of the optic nerve. And so that gives you your orientation. You almost want to put a finger here and a finger here, and you want to make the cut this way. See how that knife is going in? This way. Be careful if the vitreous is there. Sometimes little stuff will squirt out. So don't be, over the top of it. Oh, you'd be all upset. You probably wore the big face shield during COVID and all that stuff. No, just a mask. No goggle. No. So you'll get my philosophy about COVID and masks and stuff like that. I mean, you're the healthiest people in the world. It's the stupidest thing I've ever heard. Oh. You guys all went through the worst of it in school. Goodness gracious. So you can see the way the cut is. So you're cutting along the perimeter, but the orientation, this would be however you want to do it. So it's basically a cut, not this way, but that way, because you want to open it like you would open a book, and then you begin to see the inside. You'll be able to see the delicate membrane of the retina. That's that tapetum I was telling you about. You can see it here. See, it's like a little reflector against the dark. This is what's left of the retina that they pulled away. It's there. And then you turn it the other way around. Here's the lens. And you'll be able to see all those things. And you see those are the suspensory ligaments. They're still, residually still adherent to the lens. But notice how opaque the lens is. And you'll see how opaque when you look at the cornea from the inside over here. But you'll see the iris, the opening. The pupil, the opening, and the iris surrounding it. Okay? That's really, so I'll leave this so you can look it on your own systems. and then we can get started, and then you can go. You good with that? Particularly the go. 50 minutes. Wasn't bad though. There's a great saying in Yiddish, nicht gefährlich. Not so terrible. Yiddish is a very expressive language. I was from an age where, stop recording.